record to... Okay, let's get started. All right, so what we're going to spend a lot of time on today is going to be the TypeScript type system specifically. There are a lot of, not a lot, there's a decent set of TypeScript features that I would say aren't the type system itself, but I think most of the power is downstream from really understanding the system itself. For this talk, I'm using TypeScript 4.9.4. So if I click in the bottom right here, you can see 4.9.4. This is the latest stable version of TypeScript. It's about 3 weeks old. Actually, no, it's even newer than that. TypeScript 4.9 only just came out 3 weeks ago. There's only one feature I will be using that requires that most recent version of TypeScript. And then I'm also doing today's talk in VS Code because I could not find a single web editor that is yet updated to this version of TypeScript. And I was hoping to use one of the new features. Did I hear someone? Yep, go ahead.
Is there a change log thing somewhere that you would recommend, which is like per TypeScript version, what are the new features? Like,
oh yeah, 1 second. Yeah, it's funny because just yesterday I was literally just going through the pull requests for the next rev of TypeScript. So there's two that I use. So here coming in chat is number one. So that is the GitHub release notes. So they are pretty raw. And then here's the ones that have like been made well. It's a weird way to frame it, but have been prosified by people. So the second link is where you can see all the different versions of TypeScript, the large evolution. TypeScript does a kind of what's stable ships style of development. So if any of you were to go look of what's currently slated for TypeScript 5.0, when they cut the branch, whatever is ready and whatever is not is not. So they do timed releases. So TypeScript 5 has a specific release date. They do not do scoped releases. So for those of you, for instance, that know what decorators are currently slated for TypeScript 5. They were also slated for 4.9 and 4.8, and I believe 4.7, and just keep getting pushed back because they have not yet been stable for branch cut. Part of that is also just because of the fact that the proposal had not been ratified or is still not finalized. TypeScript will often land features that are not fully ratified by ECMAScript. They'll just be gated behind a flag and then transpile down to them. If none of that made sense, don't worry. Okay, so now we're going to start the deep dive. I know I called this an expert talk. I will say this will bounce back and forth between advanced and expert. You don't have to be an expert programmer or need a CS degree, I think, to follow this talk. It's just that the concepts themselves are on the more advanced side, and I may mention advanced content along the way. All right, so with that, let's get started. So the first thing I want to start off with is make sure that we have a really good understanding of what are types. For anyone who has attended my type theory talks, we've gone through that question a little bit, but I want to approach it from a TypeScript-oriented framing, although it'll be really similar. And so really what you should think of a type is a set of rules, that construct the instances is really what you should think of a type is. So like when I say the type my Boolean, we are really just saying it is like the types, my true, my false. And this is valid TypeScript. So you can think of a Boolean being a rule that denotes all of the instances of that type. So we just say Boolean means there are two different instances. There are two different values. And likewise, you can think of char is saying there's 256 values. Int 32 is 4 billion different instances, but it is the shape of the allowed instances. And so when we then say, for instance, let x be a Boolean equal to stuff, what am I allowed to put on the right side of this equal sign as a literal?
True or false?
I can put true. I can put false. I can put any of the instances of the Boolean type. Okay. I want to then really go through in detail what is happening in both of these lines and make sure we understand each piece of them. So if we start off with what's on the right, and I'll get rid of the second one for a second. So here on the right, I have false. False is a literal. All a literal means is that it's literally that value. It cannot change. It is a constant of the universe. Like 7 is literally 7, right? So false here is a literal. Does anyone know the type of false? The literal.
It is false.
It is false. This is a decision of TypeScript. Right? So in a lot of languages, the type of false will be Boolean. The type of the constant, the literal false, is false semantically. But we have to be careful because the way this manifests is not necessarily always consistent. And what I just mean by that is when you mouse over stuff, I don't even think it'll let me mouse over this constant. But we could imagine saying, for instance, a type deno equals type of false. And if we look, we can't even ask the type of it. All right, so this is what I mean just by like the presentation of stuff, we will notice is like inconsistent. Type of does not let you actually put in literals, is why this doesn't work. So there's like no way to ask it the type. I can't hover over it. And so there's no way in this editor for me to actually ask it the type of this literal. So you just have to know its type is false. To make sure that makes sense, does anyone want to guess what the type of this thing is?
89.
89. Does anyone want to guess what the type of this is? Someone else want to guess what the type of this is?
String hello.
It is the string hello.
And basically you can say that the type of all literals is themselves or something like that, right?
Correct. The type of a literal value is literally that thing. And this is going to apply to Boolean, number, string, symbol, which I'm not going to talk about today, big int, which I'm not going to talk about today, and that's it. All the primitive types of TypeScript. So for the primitives, they are their type. Okay. When we look at line 7, what is the type of X?
So I have a question. Is a float not a primitive?
In JS, number is ints, floats, all of the above.
Okay, I missed that. Yeah.
If you go deep into WASM land And the deeper bowels of JavaScript, you will find float 32s and other stuff if you want JavaScript to bridge into a CFFI and all of that. We're not going to talk about any of that for today. So we'll just talk about like general browser JavaScript stuff. Number is
I was temporarily mesmerized by the use of big int. Yeah.
So there is
Where's
that-
the float?
is-
So ignore.
does ECMAScript say that numbers are float 64s, or is there any sort of stake in the ground on that?
Yeah, I do believe ECMAScript says that floats are 64s or int 64s, and that there are conversion rules swapping under the hood, or I actually don't even know. There's something specified about that, but I've not read that portion of the ECMA in a while. ECMA. All right. All right, so going back to this line, what is the type of X?
Boolean.
Boolean. Why is the type of X Boolean?
Because you said so.
Because I told it. So the important thing for everyone to see here is that line 7 is actually two different lines. It's these two different lines. It is the declaration. There is a variable X that is a Boolean that exists, and then I put false into X. So even though false, as Shards mentioned, has the type false, when it is put into X, X, the variable, has its own type associated with it. It has been declared to be a Boolean. If after line 8, I were to console.log X, does anyone know what it would be?
Undefined.
It would be undefined at the runtime. And then if you look here, TypeScript is smart enough to say you really should not be doing this. So TypeScript is actually blocking us here. If we turned off strict mode, or for a second we just pretended we were in JavaScript land where we don't have types, your runtime is an undefined. And notice actually here the error went away because this line right here is equivalent to X being any. And so this is now allowed because any can have the runtimed value of undefined. So anyway, just keep in mind that this line that we had is two different things. So now I can say type of X. And what will happen when I hover over G?
Boolean.
It is false. This is where we start to get into some weird, subtle stuff we have to be careful of. This is type level. And when you operate at the type level, it will be smart and narrow, and it will narrow down your types as tight as they can. You're going to start noticing this is what the type level does. Because it can see this here. If we didn't know where this came from, it would keep it as Boolean. This is one of the things that like you have to be careful with the type system is it will just try to narrow tightly when it can. And then like they're always trying to add rules to make this more and more what you would expect. And I think Shards, you've already noticed this sometimes you're like, I'm surprised it narrowed it. But so just be aware sometimes when you do these things, it might peek through and say, I know what the contents are.
Is it because we don't assign X as anything else after? Like if you did it on line 8, X equals true, does that mean G is a different type now?
No, G is true.
It's doing static analysis and figuring out that it can only be that.
Yep.
type at that point. If you had like let x Boolean equals some function that returns Boolean, then I think it would end up at Boolean because it would have no idea unless it. So now I think G is going to be,
oops. There we go.
G is going to be a Boolean because it
Boolean.
can't tell anymore.
It can't
Can't
tell.
do static analysis anymore.
Yep. So there are places where it will try to analyze and be smart. And the tricky thing is because static analysis is heuristic based, sometimes you will get as good as the analysis is. So in this case, when we do this, it is clear that X is true for the entire lifetime of the program, everywhere. The second you do even slightly interesting stuff, that changes, as we saw with calling the function. Okay. All right, so as we saw in here, the type of the variable X is a Boolean. It's what we've told it it is. What this means is that you can put a Boolean into the variable X. So I can assign X to be true. I can assign X to be false because we've declared that X is a variable that holds Booleans. So think of this as saying X can have a Boolean inside of it, whereas you should think of this expression as what is the type of the contents of X? In which case we saw it might statically analyze something tighter. And by the way, this actually works at runtime as well. So you could actually do that and have this run at runtime. Cool thing about TypeScript is if I put string here, are we in strict mode? Let me check. Strict is on. Okay. I would have expected this to actually say this is never possible, but sometime maybe that's TypeScript 5. Like at some point, someone has to add the code to say, hey, this could never be true. Let's add a compiler error for that. So I guess that one doesn't exist yet. And I meant equal signs here. So anyway, the declaration.
So how would you get it to say to get it that it's a Boolean? You know, how would you determine that?
Oh no, if you want to know at runtime if something is a Boolean, this is what you would do. And this will only run if it's a Boolean.
Oh, okay.
Like if the contents of it are a Boolean.
Yeah, the runtime types are a much smaller set of things they can be than the compile time types. Like you only have Boolean number, big int, object.
Yes.
Right.
The type of operator is a runtime function in JavaScript that has very narrow breadth to what it can return. The TypeScript type checker is aware of what the type of operator does at runtime, and therefore also has a bunch of heuristics of what it does at type check time as well. But so then notice though, when I write type, x type equals type of x, this is happening at compile time. So when this gets compiled into JavaScript, this line is gone. Everything type level is gone. And so this is just the TypeScript type checkery stuff, where it's doing that narrowing by doing static analysis. JavaScript doesn't do any of that.
I guess it's the thing that's tricky to keep in mind is that there are two fairly independent type systems, one at compile time and one at runtime, and the runtime one is really crappy.
Mhm. Yep. So then we see this declaration here to repeat what we've seen so far. False has the type false. Here we've declared a variable with the Boolean type, of which false is assignable. So both were allowed. I could actually say here, I just want X to have the type false. Notice this line is not allowed now. I'm saying X is a variable that can contain the value false. So this is okay, this is okay, this is not okay, and neither is that, and a bazillion other permutations. You'll notice, though, an interesting thing. When I omit the type, and I just do that, TypeScript has the option of thinking you meant this or this. I mean, it could also put any. Like, there's a bazillion set of types it could put there. So when we do this, TypeScript then has to choose what should it assume you meant. And I would hope all of you would have the same intuition of what you probably want here is the word Boolean. And so what TypeScript's going to basically do is say, whenever it's ambiguous, I'm going to put something here that doesn't use specific instances. So even though this is a specific instance of bool, when you don't tell me, I'm going to assume that this is supposed to be a bool. I'm going to assume that you meant a number here. What's it mad about? Oh, I have a y below. I don't need that for now. Right, so it's just going to assume you meant 9. Now, I could have said this literally is 9, in which case I can reassign it to 9. I cannot assign it to 10. Oop. Because it's literally 9. But when I just put this, these are both valid. And when you don't put it, these are valid. Okay. So here it's going to assume we meant Boolean. There is an expression you've probably all seen now, maybe, as const. As const is the way to hint. I'm thinking about stuff as literals. So when it saw this, TypeScript is just like, oh, it's false. I know its type is false, but like you probably want a Boolean. And so it like does that thing I talked about. When TypeScript sees the as const, TypeScript looks at this as like, this is false, but I really mean this is just false. I'm pointing out to the fact that this is a constant. So then when TypeScript sees this, TypeScript's magical inference engine is like, I think this programmer is being really specific. But notice what's happening here. All that TypeScript is doing is trying to guess what you meant because you didn't write it. So let's be super clear. What is the type of this? What is the type of false as const? It's just false. What is the type of just false? It's also just false. So these two expressions both have the exact same type. They are the type that is strictly false. Both of them. Both of these have like an omitted invisible type specification that the TypeScripter, the type checker has to figure out what did you intend. And so here it looks at it and was like, even though this is false, You didn't go out of your way to be really direct about it. So you probably want Boolean, and you'll be happy I filled that in for you. Here, the type inferrer says, you're being awfully specific today, so I'm going to assume you meant false. So notice this is the type inference engine taking cues off of what you wrote. That is why these two get and be inferred to be different. I know I'm being very clear here, but the takeaway I want to make sure you have is this expression and this expression are the exact same thing. It is just the type inference engine reading your code, choosing to fill in a different variable argument because you didn't write one. Go ahead, Paige.
If I type let v equals false, it tells me that v is Boolean.
Yeah.
Oh.
And X here is false. Yes, what I'm saying, Paige, is imagine Shards comes to this code, and Shards loves annotating every variable. And like he hates that you don't for whatever reason. So he comes in, he's like, I'm going to annotate Paige's code. I love annotations. And he looks at this and it's like, oh, Paige just wrote the code v equals false. Shards knows that false literally has the type false. But then he has to think of, if Paige had written a type annotation here, what would she have written? Now, Shards could write any, and that's fine. Shards could write a number or a Boolean, and that would also be fine for this variable. Shards could write true or false or 8, and that would also be a fine declaration for this variable. But Shards wants to write in what he thinks you intended as the programmer. And Shards is going to say, I'm seeing false being put into a mutable variable. I'd be willing to bet Paige wanted this to be a Boolean. I can't be certain, but I'm like 99% sure that if I put this, she'd be like, yep, that's what I intended V to be. Then Shards comes in and sees this line. And again, Shards knows false as const has the type false. It's literally false. But Shards is going to look at this and say, why did Paige choose to write as const? What was this doing here? And I think what she was doing was saying, I really mean false the constant, not false the instance of Boolean. She's trying to tell me something here. So when I annotate her code, I'm going to put this as the mutable variable false. I don't know why she would do that, because why is it mutable when it only has one instance? But I can't think of another reason she as a programmer would have put that there. So she appears to be pedantic today, so I will also be on her behalf. That inner monologue that Shards just had is what the type inference engine is also doing, and why it is saying V is a Boolean and X is a false, is it's literally having the internal monologue I just made Shards have. Did that clear it up? And then Hyperjewel, you're muted or practicing ventriloquism, or... And now you're erasing an imaginary whiteboard. I will come back to you when you find, dissolve your microphone shenanigans. Okay. So let's consider two.
I have a question.
Go ahead.
Is the
Can you hear me?
reason?
Sorry,
Oh, sorry,
Hyperjewel, go ahead, and then I got you.
Oh, sorry, I had wrong microphone input set up. My question is, so V is still false, but it's also a Boolean. Maybe I'm not fully following you,
Yes.
because it would be inferred as a Boolean, so it's also a Boolean, but it's also type false, or is it just always type?
Type and there's the value.
Yeah, go ahead, Shards.
Well, there's the type and there's the value. I mean, the type is Boolean, the value is false.
Yep. So the word let means that this identifier can have its contents changed. This is a specification of all of the contents it is allowed to have. This is the current value that is stored in that identifier. And so when you write let v equals false, you have not told us what v is allowed to hold. If this were JavaScript, you could just write v equals poodle, and that would be fine. In JavaScript, you can do whatever you want. In TypeScript, we're trying to prevent you from making mistakes. And so we want to say v as a variable is meant to hold different types of things. And so when you don't put it, just like the monologue I pretended for shards, it's just going to assume you probably meant this. And so all this line is saying is v is an identifier. It is allowed to be changed. It currently has the value of false, and it is allowed to have the values true or false at any point in time. So you should really just think of Boolean as just meaning true or false, the value.
Right, and the other one, because it's a constant, can only ever be false. That's the only
Yes.
value it could ever have. Okay,
Yes,
okay.
but
I just wanted to clarify that. Okay.
No worries. The thing you want to be clear of, though, is that this line is missing the type identifier. You haven't specified one. And so when it sees the as false, it is saying, I think you meant this. And so because it expands it into this line is now saying there is an identifier x whose contents can be changed. They are currently the constant false, and they can only ever be the constant false. Like, now that I've specified the constant is false, if you were to write this line, you don't actually need that. Like, this is just saying I'm only ever allowed to have false, and I am false. So all you should think of as doing is that the as const was helping hint the inference engine that the missing thing you didn't type was super narrow, just the value false. So that's equally okay. These two are doing the same thing. But when you omit the explicit type, the inferer is going to actually label your variables differently for you because of the hint. Hartnell?
Yeah, so is the reason why it narrows down in this way is because you can declare a variable that can hold true, false, or 8.
Yeah, so let's do a slightly more complex example to see if this helps. So imagine I say, let k equal 987. What would you imagine is the type of k? So Shards comes in, he reads Hartnell's code, and is like, Hartnell forgot to annotate this variable. What does Shards assume you meant as the type for k?
List.
A list of numbers.
The numbers, yeah.
And by the way, this is the exact same as this. It's just so when you write this, if you instead write it with square brackets, it's just syntax sugar for the exact same thing. So Shards is going to come in and assume, oh, look, he's got a list of numbers. Okay, then Hartnell comes in and instead writes this. So now Shards is like, Hartnell wrote as const here. What did he mean? Now, Shards is going to have a few options. So there's the line you wrote. So let's think of the possibilities that Shards could think you meant. He could say, I think he meant an array of 3 numbers. Actually, that should not be our, I don't mean these in a specific order. You could say, okay, no, I think it's a list of numbers. You could say it's the tuple of 3 numbers. You could say it's a 9, an 8, and a 7 explicitly in a list. You could imagine the type of that expression is a 9, a number, and a 7. Hopefully that one is obviously a bad choice. You could assume that this list was a 9, a number, and an any, and infinitely other possibilities. So now Shards sees this, and Shards needs to try to figure out what this expression means. Now here's the tricky thing. The second you as the programmer write the type, there's no ambiguity. So the TypeScript team had to come up with a rule for the inference engine of when you don't put a type, which of these should they choose? And they may not have chosen the best, but they did choose one for the inference engine. So I hope we can all agree that J3 and J4 and anything like those would be terrible ideas. And I hope we should all conclude that the answer should be one of these 3, and that anything else would be a terrible choice. We should also be able to rule out J0, because that's what you get when you don't put the as const. We already know when you meant that. So we have the opportunity to choose something different. So now, if we are inventing TypeScript and we look at line 12, we're going to have to conclude it means either 14 or 15. The creators of TypeScript chose to do line 14. And so what the creators chose is, we will interpret the structure as const, but not the values. And the reason they chose this is because you put the word let. So you're saying here, something is mutable. What is mutable? And it's probably the values. And the reason they did this is because it allows the language to easily support tuples. And so again, the short answer here should just be, when you have a value you write as const, TypeScript has chosen in the inference engine to say, you are explaining to me the structure. So if I mouse over this, and I was wrong. It is actually said, this is the immutable 987. So we can actually see TypeScript went all the way down to that last one. And forgive me for being wrong. This really comes down to, they got to pick one. So actually here, it did narrow it all the way down to the literal, which actually I guess is good. Oh, sorry, I made a mistake earlier when I said something. I was starting to confuse myself with structural typing. What I should have said here was, and we'll talk about the structure thing later, the TypeScript team chose to avoid ambiguity. It's always the literal everything, always. So the structure versus literals we'll talk about later, but so we can see here the type of J is the array 987. It's read-only, which means you can't push or pop from it, is the type of this expression. So it will literally take, right? So if I just put in here banjo, J is 987 banjo. It's always the literal. No ambiguity. Hartnell?
What I was asking is, when typo narrows down to like a literal type, does it do that because you can have a variable with the rules true, false, and 8? You really can't say that variable is a Boolean. It's just the contents that you can say anything about.
Yeah.
Those kind of rules.
So every variable in TypeScript has an annotated type. And if you don't write it, it's just inferring it for you, but it still has one. So here we can see if I say type capital J is the type of J, we can see TypeScript is saying, yeah, that's the type I'm inferring. And then as we saw earlier, if we just reassign this later to be that, it's upset about something. 6 is not assignable to 8. Because of this as const thing, it's being really, really tight. Same thing we saw here of X now is only ever assignable to false. You should basically never have the as const keyword and a let, because this let is now only assignable to this one thing literally.
Okay, but I'm not talking about using as const. I'm talking about when you declare the Boolean and you make it false by default, and you wind up with false as the data type. Does it do that because you declare variables that really aren't Booleans? Like the
But you
example
mean
you
this
gave,
line?
true, false, and 8. Like the one you defined as the rules being true, false, or 8.
So if I
That
do,
you can't really, if you can't really get a type of a Boolean from that. It's not a Boolean, you know.
yeah, so
So
if I
does
do
it narrow
this
it
line
down?
if I do this line right here, I can assign W to true, I can assign W to false, I can assign W to 8, I cannot assign W to 9. If I,
Ergo, so type of returns the literal type in this instance, and this is why it does that narrowing, correct? That's why I'm
so
asking.
if I ask it what is the type of W, the type of W is a true, false, or 8.
Oh, okay, cool.
So this is the type. And we can notice here it's not doing that static analysis because we've done all sorts of stuff. Here it should say false because it's like, yeah, this is clear. Now we're starting to do enough stuff with it where the static analyzer is like, I think this really is that whole type. But when this is your entire program, TypeScript is at least smart enough to say, I'm sorry, but this is just the value false.
Oh, so it actually looks and says you can actually use a true or false. I mean, you can use true or 8. So
Yep,
instead of
W is
false.
never reassigned. And so it's clever enough to say W is the value false. I actually don't like that it does this because it leads to inconsistencies and you're in this hedonistic treadmill of always making it smarter and smarter and smarter. I would personally like it if when you write an explicit type that should be the type, but it wasn't up to me. No one consulted me. I'm just kidding. But all right. Okay. So hopefully that gives us a better sense of consts, lets, and we've really belated these lines. Okay. So the next thing I want to look at then is when we take these exact same expressions and we instead make these ones, put the const keyword. What does that do? What is the type of V2? So we know V1 is just a Boolean. What is V2? So
False.
yeah, it's false because this could never have any other value. Now here's where we got to be careful. What is the type of W2? This is one of those things where it's like, well, what did they decide? Did they decide to do the heuristic thing or did they decide to listen to my type? Right?
Hope they listen to type.
Listen to the type. And there's some inconsistencies in these rules I don't really like. But luckily we can at least just mouse over them and see them. But okay. All right. And so you can almost think of const is if you put here does nothing new. Right? So because they're already const anyway. Okay. So then I guess one last example, if I do let fox equal name is Foxy, I don't know, just Foxy, and age is 43. If I hover over the fox variable, so again, someone comes in, Mr. pedantic and says, I want to add in the type, what do we think the type of Fox should be?
A name to string and age to number.
So the tricky thing again is because this is the inference engine is a set of rules of what do you put when the person didn't write it themselves, which is just a bunch of rules that you got to kind of get to learn as you spend time with TypeScript. And TypeScript did what shards implied of it took the structure, this is what I was saying earlier, but not the values. Because that's probably what you meant. But now notice, this is what TypeScript is saying, is if I come in and I rename, Fox changes their name, they decide they want to honor their parent. Oh no, sorry, they have a child and they're like, I want to, take on senior, right? We assume that you might be changing, and that's a year later because they had a kid named Foxy, that this is probably what you want to do. And then when you come in, you say fox.address equals tree number 9, it won't let us do that because this doesn't have an address. But now notice, it's because it's assuming that we wrote this type. It filled in for us, I think this is what you meant this thing to have, so this is not allowed. But we could have actually said that the type of Fox is name is a string, age is a number, and there's maybe an address, which is a string. And now this line is allowed. Also not having that line is allowed. But if you just came in and you were going to annotate the code, no one in their right mind would have imagined there's an imaginary third parameter called address that's a maybe string, which is why it can't possibly infer that. Now imagine that you actually wanted this thing to just be like a bag of stuff, and you could randomly insert whatever you wanted all day long. And we'll do magenta. Again, no one would likely assume that you meant this to just be a random bag of stuff. And so if you wanted that, you'd probably want to tell TypeScript that this is a bag from strings to whatever the heck you want. And that's all this type means, is it just means curly braces where the thing on the left is a string and the thing on the right is whatever. Or I could tell TypeScript that this is allowed to have the keys are a string and the values are a number or a string. So now if I come in and I say fox dot is happy equals false, it's not allowed. And we can see Boolean is not a, right? So this is, Fox is allowed to have any key you want, right? Because this is the same as saying square brackets string, right? That's the same thing. But we told it the values have to be numbers or strings. So this now is not allowed. So TypeScript does allow us to specify when we have these curly braces, is it any key with certain values? Like I could say the only keys allowed are name, age, or address. What doesn't it like? It is now saying address is missing. A record must have all of its keys. It's like a database record. So when TypeScript sees this special annotation, it is saying it has all of these keys. So in this case, these three are now not allowed. So TypeScript does have all of the ability for you to describe the shape of this. And when you put nothing, it's going to assume you meant these keys and only these keys with the types of the values as if it was using all of the same rules we saw earlier when we were learning let syntax. So if you wrote this and it's going to infer this was a number, then we're going to infer this is a number, And those are the rules it uses to get name is a string and age is a number. And to make sure it's clear when I say we use those rules, so we can see that, if I put as const here, what is now the type of fox?
The string age to 43.
Yep, so the name is a string and the age is the constant literal 43. If I said I wanted the whole thing as const, then we would have literally that thing. The fields aren't modifiable. So the whole thing is frozen. You can't add keys, you can't remove them. And so if I now say fox.balloon equals 6, we can see balloon is not one of the allowed fields. If I say fox.age equals 45, age is read only. And so like if I were to say delete the key fox.name, you cannot do it on a read-only property. So like this fox thing is stuck. You can't modify it. The one thing I can do is set fox equal to another instance of that same thing because I used the let keyword. Why you'd want to do that, I don't know. Just making sure we explore and understand these attributes. You did see the read only keyboard by the way. You're totally allowed you are not allowed to use it in the dictionary itself. You can use it on the outside of oh no, you can only use it in classes. Didn't think that one through. Read only as a property accessor in classes. Can't use it in naked objects like this.
But it's inserting it into the object somehow.
Yeah. Well, the thing when I was trying to put this, I'm just moving too fast. It's a type level keyword, right? So if I specify the type of this object, I can say the name field is a read-only string, and
Okay.
the age is a read-only 43, or this is a read-only Foxy, or this one is mutable, but it can only be the thing Foxy, or it's mutable, but it can only, right? So I was just, when I tried to put them here, not thinking, because they're type, right? This right here is a type. And you can actually give types names, which, right, so type Fox, and then here I can just put that type. This is how you name a type. Okay, so that is a good step into the next thing I want to look at, which is, so we talked about what are types. There's my answer. And then I guess we just looked at let versus const and as const. Okay, so now I want to look at for the ways to construct types. So as we know, there's the literals. So we can call them the primitives. So there's number, Boolean, string, symbol, big int. Then there's I will call them, and they're primitives, but I'll put them in quotes. The other primitives, which are null, undefined, any, and never. So let's talk about those for a second. So these are all types. So let me say, let y be a null, and it equals, so what are all of the things I can put inside of this variable?
No, that would be it, right?
That's it. Null, just like false, is a specific value, and then also happens to be a type with just that value. Undefined is precisely the exact same thing. Null and undefined in JavaScript and TypeScript both mean nothing. Undefined is meant to be the contents of this variable. Right? So if you were to actually print this, it's undefined, like at runtime. So undefined is meant to mean never defined. Null is meant to mean absent. If you're wondering why the heck does a language have two versions of the null concept, welcome to JavaScript. I think it's a design mistake too late. But so like when you're literally writing a function like get username, and you could say it returns a string or null, and I don't care how it's implemented, or you could write that function to return string or undefined, or string or undefined. Like you as a developer get to figure out what you want the doesn't have case of this to be. Most API creators would do string or null, for null meaning absence and undefined meaning has not been set. But those are semantics. There's nothing in the language that forces you to use them that way. So I really like to just think of them as null and other null. Welcome to JavaScript. Oh, I forgot another one. Okay. Any should be super straightforward. What can I put here?
Anything.
Anything. I can put a string, I can put an integer, I can put a float, I can put a Boolean, I can put a tuple of a Boolean, a string, and number, and a dictionary. Like you can put whatever you want in an any. Let me swap never and unknown. Does anyone here know what unknown is? So let's start off with what can you put inside of unknown? Anything.
Thing, yeah.
So at first blush, any and unknown should feel identical. They're not. I really wish any, so let me actually put here, null and undefined are both null. Undefined means not set, and null means missing, whatever that means. Or this should be maybe uninitialized. And I should put there, that's a convention. Okay. Any is really leave me alone, TS, I am JS. So if you've ever programmed JavaScript, JavaScript lets you literally say, you know, Z equals 9, and now Z equals hamburger, and JavaScript's like, yep, that's fine. You can put whatever you want, wherever you want. And so any is literally saying, Z comes from the land of JavaScript. It is the wild, wild west. You can do whatever you want with Z. You can do whatever you want with any. And I mean anything. Here's why this is dangerous. Let G, I'll call it data, be a string. Right, so in normal land, I can now reassign, right, the contents of the string, and we're all used to that. I cannot put a number in there. Everyone should be good with that. We also just saw if this were an any, I can put anything into that. Okay, oh. Right, and everything is kosher. But look at this. If I say data is a string, and then I make rut row be an any, I can assign data to rut row. So even though data is supposed to be a string, you can put an any into it, which is really bad. This almost means like when it sees string, it's like string or any. So any is this really perverse type where when you have it, you can break everything else with it. Welcome to the land of JavaScript, aka the Wild Wild West. If you are a good TypeScript programmer, you should never use the keyword any unless you are bridging with JavaScript code or prototyping with something and just want the type checker to get out of your way for a second. If you're writing good, mature code, you should not be using any because of this line, that any relinquishes the type constraints of anywhere you pass it.
Isn't there something with generics where you need to use any as on templated types or something like that?
Not that I can think of. There used to be.
Okay.
So when TypeScript was first invented, it needed a way to allow you to partially type code so you could incrementally adopt TypeScript. So you should really think any does not really mean any type. You should think of it as JS, STFU. I wish they had like given it a better name of like, this is the escape hatch into Wild West BS code. Like they could have given it a better name. And BS code is, by the way, VS Code's younger sibling that never works. So if you want to say, what is the type that is string or number or Boolean or null or undefined or everything in the universe? That type is unknown. Unknown is the type of everything. But now, so let me make, so rut row was any, and wrote raw, let's just call it bad and good. Okay, so if I then say data, which is a string, equals bad, it's like, yep, cool. Go ahead and put your number 8 inside of the string variable. Why not? And then find that bug 3 days later and say, ugh, I hate my life. But if you try to put good inside of data, unknown might not be a string. So you should think of any is this really bad way to bridge into JS. And you should think of unknown as what you thought any always did. So unknown.
Did you say they have the same left-hand side behavior, but they have
Yes.
different right-hand side behavior?
Any, but any can be assigned to any variable breaking type guarantees. Any breaks the type system. Any is one of the, I would say, 2 main things that makes TypeScript unsound. Because it means this right here, you can't actually ever know actually has a string in it. Unless you promise the code base doesn't have any's, and that the code was type checked in strict mode, and that TypeScript has reached the point where it has no bugs. But as we know, no programming language actually can reach that level of guarantee. Okay, never. What can I put here?
Nothing.
Nothing. Never is the type that doesn't have any instances. You might wonder, why does the language have this? We will get to that maybe today, maybe in part 2. I just realized there is another keyword, void. If I put void here,
Can you combine never with other keywords like a Boolean and never? Or
we'll,
never?
we will
Or never.
we will get to never in a little bit, I think. Let's just skip it for a second.
Okay.
Then you also, what?
Acknowledge.
Okay. And then you also have void. Anyone know what I can put on the right for void? We can
Void.
just try. Can I put false? No. Can I put 8? No. Can I put null? No. Can I put undefined? Yup. Can I put void? No. So a fun thing for you to know, shards, because you'll notice there's a red squiggly. Void in JavaScript is actually a function, but well, it's not even a function because if you notice I didn't put any parentheses. You can go Google this or just ask it to me in another talk of whatever the heck this is and why it compiles. Goodbye for now. But I think this is the more accurate line to put. So here's what to think of. When you write a function in JavaScript, print hi. What is the return value of this function?
Void.
Well, imagine when this returns and you could somehow put its contents inside of a variable by tricking the language, right? So if I did const x equals print hi as any, and I just broke the type system, and then I console.log x, what really is going to be inside of x?
Undefined.
It's the uninitialized, nothing's really gone into x. So it's going to be undefined. So we can really think of as there's an invisible return undefined at the end of this function, invisibly. Like these will now do the same thing. But if I then said this function returns undefined, that's not really what I'm intending to tell you it does. Undefined is a very special value, and I'm not really trying to return that. It's an accident. So what you really want to do is say, I'm returning void, which means I'm returning nothing. But we can't say never, because never would mean like the function it never returns. Like you never can have a never. And so void, just like you've seen in C or other languages, means that it returns the absence of information, the instance of which is the uninitialized data. And then you might be like, ew. And the answer is, you are correct. This is shimming the behavior of this line in JavaScript has to return undefined. And because it has to return undefined, in TypeScript, you would never write this line. You would just write this. And this should look like a happy thing of, yeah, it returns void, there's no return statement. But because JavaScript at runtime would put undefined in X, TypeScript then allows you to explicitly do the behavior. And then the only way this will compile is if it allows undefined to be assignable to void. Here's more sadness. Luckily, well, I shouldn't say sadness. This is happiness, but will feel like an inconsistency. So here, I can't put undefined in XYZ, which is good. But if you remember here, I told you that this is equivalent to this in JavaScript. This one TypeScript chose, this is not allowed to uninitialize and then initialize. So like here, I feel like TypeScript did the thing to make TypeScript good. And here it did the thing to make JavaScript compatible. Like it really should just say this return statement's not allowed, but say la vie. Although, quick side note, if any of you attended my type theory talks, you will remember that void is actually the type with one element. And so this type does need a single element to be sound in type theory. And undefined is actually the logical thing to give it. So I squintingly support this decision. Okay, and I know we didn't do never yet. We'll get back to it. Okay. So I'll call these the special primitives instead of the quote primitives. Okay. There is another way to construct types. Array T and T square brackets. I'm not going to say anything more about them. We saw earlier record. I will just touch, I'm not going to say anything more about that. You saw me use it briefly. It's just a pretty way to describe different setups of this thing. You can make this an enum. You can make it a union type. There's also map. Notice that this is a class in JavaScript, so you'd have to say new map. Map is basically your hash table, so you can actually use keys that are objects and all sorts of stuff. It's type safe. There's set. Those are generally your kind of container collection classes. I'm not going to say anything more about those for today. So then the next thing I want to talk about are unions and intersections. These should be pretty straightforward, but I'll spend a little bit of time on them. So a union is, you should think of these words in terms of set theory. So if I told you in math, I have the set of 5, 6, and 8, and I union with the set 7, 4, 2, and 8, and I put those sets together, what would the set be in math? From lowest to highest.
2, 4, 5, 6, 7, 8.
Yep. So just like you learned in set theory, right? So, and if I instead did intersection from lowest to highest, what is the result?
8.
Just the element 8. So intersection means overlap, and union just means the thing from both of them. So if I say, let data be a number or a bool, now when I say or, and I'll just for a second put garbage over there. Remember, we learned earlier that any can be assigned to something and ignore the constraints, right? So whatever I put here, I'm breaking the type system. Okay, so what am I allowed to put on the right side of this? I'm allowed to put the union of all of these and all of these. So what are some examples?
2, 4.
3 more.
False.
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 Yep. If I were to declare another variable, is there a difference between data in data 2 in terms of their capabilities?
No.
No. Another
In fact,
interesting.
we saw the hint to read this the other way earlier.
Yep. TypeScript will also let you put a leading bar when you do a union. It's just a design decision they decided. The reason they made this decision to just, it's optional. To allow that is when you choose to format your code this way, it has a certain read to it that this doesn't. And so if you want to, just know that that leading pipe is allowed. It's just to make it format a little more pretty. And that's it for the union type.
Does that work with intersections too?
I've never tried. Yes.
Okay. At
I
least it's
guess,
consistent.
I mean, I guess for the same reason you'd want that.
Yeah.
Okay. And then by the way, I don't want to get into it here, but for those of you that like math, you'll probably notice that the union type uses half of the or operator, and the intersection type uses half of the and operator. That is on purpose, and it's for deep philosophical reasons. Think about it. The answer is pretty straightforward, but it might take you a little bit of noodling to think about why. It involves their truth tables. But okay, so now that we understand const types, right? So if I do this, what is the type of X? Red. Right, so I could then imagine saying, so colors, let make it mutable, but I could say colors is red or green or blue, and then initialize it to red. So now if I come down here and say colors equals blue, that's good. Colors equals red again, that's good. Colors equals purple, and that is not allowed. Colors can only have, it is the union of these three. This also allows us to now see our first instance of intentional type narrowing by what are called type guards. So imagine I then say, let me put this in a type just so we can use it. I'll just call it basic colors. I'll call it basic color. You should avoid making a type plural because an instance is only one of them. But so imagine I have this, and I want to ignore the value. So let's just use that trick for a second, right? Imagine we had some function that it came from somewhere. So then down here I say, and I'll just call it color. And then imagine you have an if statement. If color equals red, and then like we do stuff. Do stuff. And then we have an else statement. And we decide to log the color. In line 28, what is the type of color?
Is it green or blue?
Within these curly braces, the type of this variable has gotten narrower. This is called a type guard. There are tons of type guards. Right, so you can then also see, similarly, if I said up here, if color does not equal red, then here we know the color is green or blue, and in the else, we know it's red. Look at this. Oop. Const is red equals color equals red. It should have been able to type narrow. We have strict, we have ES next.
Color is null as any though, like, so it doesn't know what's in color, does it?
Well, no. In this if statement, because this is a constant, TypeScript is supposed to know that this expression could be placed here, which should narrow the type of color in this branch. But it didn't. Or maybe I'm wrong and that heuristic doesn't exist. This is another one of those
Well-
things. They just have to keep adding code to track all of these.
Is there anything
Oh,
different
that
in
is-
the else? Just out of
Oh,
curiosity.
both of them just say basic color.
The color can be, it doesn't know what color is.
Oh.
Statically it determine what
Okay,
color is.
Shards caught the bug. Color is immutable. And so after this bool is color is mutable. So after this line, color could change again. Right? Shards caught the bug. If color were const, now it can refine the type. That's what I was missing. Because now it knows that this variable never changes. So then this is always correct. And it's smart enough to know that this could go here and you can see it refining the type. Good catch, Shards. I was very confused because I knew this worked. Let's look at another example. Imagine I said const a is a number or string, and I don't care where it came from. And b is a number or Boolean, and I don't care where it came from. Okay. So in here, if I say if a is 7, TypeScript knows a is literally 7. Okay, well, that's pretty straightforward. If I said if the type of a is a number, then TypeScript does know down here, okay, in this branch, it's a number. Those should be straightforward. But if I say if a equals b, then TypeScript knows, well, then a would have to be a number. That's the only way that's true. And it also knows that b, console.log, b also has to be a number. Check this out. If I just make b be a Boolean, TypeScript is now mad at line 24. Can anyone tell me what the error message I'm going to get is when I hover over it?
Something about no intersection.
Yes, A could never equal B. The comparison appears to be unintentional because the types string or number and Boolean have no overlap. So because it's doing this narrowing, it's pretty smart. Here's one more example that is fresh from TypeScript 4.9. So let's make a type RGB, which will be red is a number, blue is a number, green is a number. Another type, HSV, and value. So then imagine we had, const C is a color, right? It's one of those two. And again, I don't care where it came from. So then in here, I could say, is the key hue in the bag color? So for those that don't know, in just checks if a curly brace, an object, has that field present currently. And if I mouse over color, it knows it's an HSV. Because if it has that key, it's not this one. And so again, to talk about the progress of TypeScript, 1 month ago, it would have said color is an RGB or HSV. So only in the most recent version of TypeScript did they add this as a type guard. So I guess I'll just put up here, this is a new section for a second that we're talking about, but we do have the notion of type guards. And so we saw that we can do type of x equals string, for instance, and this supports string, number, Boolean, object, big int. Might be it. Even arrays return object, but I'll just say etc. We just saw another type guard of like key in bag. We also saw it have the type guard of like union type equals specific value. We also saw union A equals union B, and I can put a comment, reduces both to their intersection. Another type guard. So imagine we had a class. So class foo. Let's do class animal. Class bear extends animal. Class koala extends animal. All right, so then if I had const A is an animal, and again, I want to not know where it comes from. So then in here, we can say A is an instance of bear. So then in here, for within these yellow curly braces, A is a bear. So this is another way you can refine a type in a specific scope. So we have instance of is another type guard. Any questions so far? Just want to pause for a second because I know I've kind of just been going quite a bit.
Out of curiosity, I was wondering if there's an opposite to intersection, or if you have 1, 2, and 8, and 3, 4, and 8, and you get 1, 2, 3, 4, and not 8.
Yes. So you basically say that again. You have like 1, 2, 1, 2, and 8, and like 3 and 8, and then you're saying I want 1, 2, and 3.
Yeah.
Yeah. So mathematically, so if this is A and this is B, what you've just constructed is called the set difference. It's A union B minus A intersection B. So we
That's
need this
logical.
piece. Does that make sense?
Yeah, actually it does.
So we
I
just
was
haven't
just
gotten
wondering if there's a keyword for it. Yeah.
there is a way to do set differences. We will. I don't know if we'll get to it in this talk. We'll see how the next 30 minutes go, but it would definitely get to it.
If
in
I
part
need
two
it,
if
I'll
you
use
want.
that. That's really logical. Thank you.
But yeah, but there. I just need to show you how to do the minus sign, but we will get there. I just don't know if in this talk, but soon. Okay. So then, we have the instance of. There is another way to type guard, which we've seen a bunch, which is just as. As, though, is not actually a type guard, it's a type cast, right? Because what you have to do is just say, const B equals A as bear. So notice that you are asserting this is true. Do this with care. Right? You never know if this is right. So this is telling it, I promise you, I know this is a bear. Whereas this is actually going to execute a runtime check. So in the curly braces you're safe. So as is a way to refine the type, but it's not a guard. What I mean by guard here is if type guard and then inside of the curly braces, knowing that the type is narrower for a second. Okay, there's one more type guard I want to cover. I just need to pause for a quick second to think of an example that is not so contrived. It's meaningless. Okay, so imagine we had this classes. This will be a little bit contrived. I'm sorry, but that's life. So we have a class that's animal and two classes that extend it. Imagine we have, you know, Yogi Bear is some bear, and who's the other famous bear? Smokey the Bear, right? Smokey Bear. Don't start forest fires, right? So then you can imagine a function is famous bear that takes an animal, right? So here I'm just going to return I'm just going to do an equality check, not the smartest implementation, right? So we have animal, bear, and koala extend it. I don't even need koala for the second. We have two magical special instances of bear, and this function is famous bear. Okay, so just to be clear, pedantic shards comes along again, is like, oh, someone forgot to put a return type. What return type would he annotate this function with if he wanted to be pedantic? It's just not a hard question. Nothing crazy.
Boolean.
It's a Boolean.
Bear.
Right?
Oh,
It returns the ORing of two Boolean expressions. Okay, so now, but then imagine down here, I had some animal, so const, you know, escapee is an animal. And again, I don't know where it came from. I don't care. And then I said, if is famous bear escapee. And then down in here, I log escapee. What is, if I hover over the escapee, what is its type?
Them all.
It's an animal. But logically, it really should be a bear. Because when is famous bear runs, we have asserted it's a bear. So here's a cool thing. In TypeScript, there's another feature called a type predicate. A type predicate is of the form identifier is type. And it is equivalent to the keyword Boolean with a footnote when it's true. So it is a magical thing that is like a Boolean with a tiny footnote. So for this is famous bear, I'm going to say the return type is A is bear, which is a Boolean, but it is a predicate about the variable passed in A. So on line 41, when I mouse over escapee, it is a bear. Because this function, when it returns true, includes a predicate that will be carried into the scope. So this is how you're allowed to write your own crazy functions. We haven't learned intersections yet, but I could actually say that this returns the predicate A is a bear with with also a VIP field, whatever the heck that means. But in here now, cool, escapee has extra stuff. Here's the one unfortunate thing about the is operator that you have to be careful about. TypeScript doesn't validate it. So it's a way For you as an API maintainer to say when this is true, when the function returns true, this predicate is true, TypeScript does not currently make any attempt to guarantee your implementation is that. So all you're doing is saying, if this function returns true, here is a fact for the type system to know about it. So I have a rule of thumb. If your function includes a typed predicate, its implementation needs to be dirt simple. Because type system escape hatches is where insanity comes from. The whole point of a type system is that you can trust your program. And so the second that you can't trust your program, like I could literally take this is famous bear and just return, yep, A is the number 7 coming out of this program. So in this if statement, TypeScript is like, yep, escape is 7, which then means I can console.log A divided by 2, and TypeScript, oh, sorry, escape, and TypeScript's like, yep, cool, sounds good, because escape is the number 7, which is absolute nonsense. And at runtime, you will get an uncaught exception. So just be careful with the is predicate. So I will add that to our type guards.
Do you want to talk about asserts at this point? Because it's almost the same.
Oh, so you mean like assert like?
No, like if you have a is famous bear returns asserts a is bear, and then it throws if it's not, then
Yes.
you can put is famous bear somewhere before the if statement, and it will carry through to the
Yeah, so
past
that's a
that
great
point.
point. So imagine I have a function do stuff that takes stuff, which is a string or a number. So as we saw a second ago, I could start this function with if type of stuff equals string, console.log stuff, otherwise console.error stuff. And so as we saw a second ago, TypeScript is smart enough to know that in this branch, stuff is a string, and in this branch, it's a number. So that's what we saw a minute ago with good old type narrowing from the type of operator. TypeScript is smart enough to follow flow control, meaning if I do this, what is the type of stuff on line 34 if I mouse over it?
Is string or number.
It's a string or a number, right? Only inside of these curly braces do we know it's just a string. But once we leave those curly braces, we no longer know that if statement is true. So down here, it's a string or a number. If I put return here, what is the type of stuff on line 35?
Number.
It's just a number. So TypeScript is able to follow flow control and know that when stuff is a string, it leaves the function. Now, this is a heuristic, right? Because if I do something like this, if something return, if I just put here if true, TypeScript knows it's a number. 6 mod 3 equals 0 no longer knows. At some point, and that's because constants are not folded at compile time. Right, so TypeScript does not see this as the literal true. It sees this as a number, sorry, as a Boolean. And that's long story of why, it doesn't matter. But so TypeScript will only go so far in following your logic. But know that as long as stuff is not crazy, TypeScript can follow it. So another thing is, what if I do this? Just like return, throw exits the function. And so if we throw, we don't get to line 36. So TypeScript knows stuff is a number. So I could similarly, if you notice here, I am checking a type. Let's say if it's, and then I'm throwing if it is that case. Right? So like, I'm basically saying cannot be string, right? If it's string, throw an error. So as Shards mentioned, I could assert that stuff is not type of stuff is not a string. Why is assert? There we go. It's namespaced. Just had to remember for a second. But so when I mouse over this, oh no, wait. No, I want the version of assert that throws. This logs an assertion. But it's not. I don't use asserts. I use explicit throws so I can throw errors with information. So I actually don't know how you assert in plain old JavaScript. I don't know if anyone here knows.
I was talking more about the making a function that acts as a type guard using the asserts keyword. Asserts with an S at the end. No, like do like, you know, function is number, taking a string and string and a number, a string and a number, string or a number, I should say. And then it returns, asserts, like a colon, asserts S is number.
Is that a thing?
S is number. And then in the body, you need to, if S is a string, you need to throw.
Oh yeah. Okay. Yeah, I've completely forgot about this feature because I don't use asserts. So thanks for a call out. Yeah, this is, so here you basically have a type predicate, and then it's, this function is saying, and if it isn't a number, it throws.
Yeah, so it lets you do this thing similar to the is, except it doesn't have to be in the if statement. Anything in the control flow after this assertion predicate will.
Yeah, so now you know that when you get down to here, it has to be a number because if it was a string, it threw.
Yeah.
Yeah, I completely forgot about this. Good call. All right, so another type guard we have is, great. Okay. So now a quick tease into what I'm going to call type gymnastics. I don't have a better word for it, but we're not going to go too deep into it. The first thing we will learn is the key of operator. So I guess we actually have seen the instance of operator. Oh, not instance of, the type of. So type of, we saw at runtime returns a string. That's how we could do if type of x equals string. Type of is also a type operator, right? So if I say type foo equals type of, and then let's just make something x, then we can see that foo made that type. So type of takes a value and gives you the type. Notice it happens at compile time. So using the static analysis, it has to know the contents of X in some way. Key of, so let's, so here we can see what foo is. So, oh, I would have to do key of type of X, or I could just use the thing we just made, X type. Key of gives you a union of the keys of an object as strings. So this will give me bar, union, quux as literal types. This is another operator to know. So you can imagine, going back a second ago, if we had type RGB color is red is a number, green is a number, blue is a number, right? Then I could make a type RGB components could be a key of RGB color. So that's red or, we'll just know it's red or green or blue. So sometimes when you mouse over it, it'll expand stuff, and other times it won't. This is another thing of TypeScript. They're all the same, but it has to figure out when to unfold. Sometimes you want things unfolded, sometimes you don't. But if I just do const C as an RGB component, you notice the autocomplete is like, okay, cool, it's one of these three strings. But so you could imagine then writing a function get component, which takes a color and a component and returns a number. I don't care how it's implemented, right? And so that would allow you to do get component of, you know, some color red, and you could like write a function. Ugh. Why won't it let me? Oh, this should be color, RGB color. Right, so you could write a function that now takes a color and a component and like looks it up for you, if for some reason you wanted to. Like, here's why you might actually want to do this. So imagine, so I make a color, so const red is an RGB color, and so it's going to be red is 1, green is 0. Let's make cyan. I always like better colors. And blue is 1. All right, so if we had a color, imagine you wanted a function like get color hex, get component from 0 to 255. Right, so I could now write the function get component, I'll call it 255. You know, which takes a that. Oh, I need a word function. And I can just return times 255. And you can now make all of these functions that don't care whether it's red or green or blue. And then now again, this is the right type, right? Because you don't want to have to write a get color, get component 255 red, and then the same component for green, and then the same for blue. And so the key of operator allows you to think of this more as, oh, well, these are just properties, right? And this would be very easy to implement. You would just say return C of the component. I went a little fast. Let's think about why this works. Get component takes a color and a component, and then it just looks that up. But notice, I can't just do this. You can't just get a random key out of a color. So TypeScript is smart enough to know that when I write this, that this type right here is either red or green or blue. All of those properties exist on C, and so this compiles. And then so now I could just down here make my color and say, you know, cyan And this would now give me the value 255. Oh, this should not have red, sorry. And this should have a second parameter, right? Get me the red component, 255. This is 0, 255. And if I try to put some other thing in there, no, because this thing has to be a key of the color type. Okay. Few quick things and then probably pause today because people's brains are melting. I'll cover intersections. It shouldn't take that long. Never and stop there. Intersections are pretty straightforward. Actually, so intersections, never, structural versus nominal. That's like a 2-minute remark. Okay, intersections. So if I say type A equals hi by type B equals afternoon and morning. Okay. Actually, let's do and hi. Let's just imagine these are two different ways people greet each other. So if I say type A union B is A or B, what are all of the valid instances of this type, right? So if I say const A U B is an A union B, what can I put in it?
Hi, bye, afternoon, morning.
Any of these 5.
Any type,
Right?
yeah.
Yep. And if I do this, we can see it's auto completing all 4 values because hi is there twice. Okay. If I make another type, A intersection B equals A and B. Oh, you can't use that in symbols. What is allowed?
Hi.
Hi. Right, so this is set intersection. Any questions on that? Okay. So let's try one more example with intersections. So A is foo is a number, bar is a string, and B is baz is a Boolean, and bar is a big int. What do the instances of A union B look like?
I think you can get a type error.
Remember, A union B means you get all of the instances of this type and all of the instances of this type.
Wow, okay. Is it gonna make a union of bar?
Let's see, where's the right way to place to mouse over this? Because it's not unpacking them. But okay, so we have a foo, which is a number. Okay, we can say, where is it? Bar is missing. And let's just put a wrong thing. What is bar? String or a big int?
What unions then? Okay.
Yep, which should make sense because if you have all of the instances of this and all of the instances of this, then you are going to either have a foo and a bar. But here's an interesting thing. If I make, let's make bar a Boolean actually. If I make bar a false, why is this all underlined in red?
Because Baz is not there.
When bar is a Boolean, there should be a Baz and no foo. Right, this is why it wasn't printing the type. The type is actually a little bit complicated to render. So when foo is a number, bar needs to be a string. Oh, and I forgot a comma. If bar is a Boolean, there's supposed to be Baz, which is a Boolean. Right, so all we're saying is this is allowed to be any of these or any of these. So you really shouldn't think of it as the bar type is the union of these. That is correct, but it's dependent on the other one. So it doesn't really fold them in some weird way. Okay, if I do an intersection type, what's allowed? Oh, I already moused over and showed it.
Nothing.
Never. Because you're only allowed the things that are an instance of this and this. Okay, let's make sure then this is clear. What is A union B here?
A struct with a number and a Boolean.
No, it's not unioning the contents of the structs, it's unioning the types, right? So it's all of these and all of these.
Oh, either
Right, so-
a struct with a bool, a number or number
Yeah, so
or a.
that's a valid
Baz.
instance. And so is that. So all you can just do is put one of these or one of these. What is the intersection?
I think we have one again.
Notice that's okay. So here's the tricky thing that we can go into deeper next time. This thing at a type level fits this type. And this thing at a type level fits this type. But it's weird because it does look like it just smashed them together. Because it did. This is the thing that actually adheres to both of these. Notice I'm using the word adheres. There's a magical keyword, extends, we will study deeply next time. It is the actual word we need to use to understand all of what's going on. Okay, so then to wrap this up, so that was intersections. So just to make sure we understand never, if I say type A is number or never, what is type A?
A number.
It's a number. Because I'm saying type A is all of these or all of these, of which there are none. Type B is number intersected with never. What is B?
Never.
I need all of the things that extend this and extend this. Nothing does that. Okay, that was my entire remark on the never type. And then finally, structural versus nominal is a comment I'll make. We're going to spend a bunch of these next time. So if I say this, and I have these two types, I can't actually use this syntax with types. But are A and B the same type? In a lot of programming languages, like if these were classes, all right, so class syntax looks differently. These are not the same class. They are two different classes. This is called nominal typing. Nominal meaning name. They have, like, they are the same type if they have the same name. All right, so a number and a Boolean are not the same. The word number and the word Boolean are different. So in TypeScript, classes are nominally typed. Two objects are only the same type if they're the same class. Objects are structurally typed. So these are the same type. And what I mean same type, here's the definition of same type. Well, let me just say this real quick. A extends B if A can be passed wherever B is expected. Here's a function that takes a B. If you can actually give me an A extends it. So this should fit your notion of subclassing. So then I can say A is the same type as B if A extends B and B extends A. And so you can see here, if a function wanted a B, you could give it an A. They're the same type because TypeScript uses this keyword and this one structurally. It doesn't care about the name. It looks at the shape of them. They're both objects. They have the same keys. The keys have the same types. They're the same. So I just wanted to leave that as a tease into what we can talk about next time, which is going to be types, interfaces, combining types with more intersection union, extending interfaces. Once we understand that, we will learn the extends keyword. And then depending how far we get, that's where we can do all the crazy stuff you've seen me do, where it's like A extends, and then like weird stuff happens. And we get into the type foo. So that'll either be end of next time or part 3. Any questions before we close it out? I'll just, I guess, put in here a note. Type and interface are structurally typed. Classes and primitives are nominally typed. I don't think anything's been missing from the notes of what we covered. Cool. So I would basically say all the stuff we're going to get into the next 2 times is going to be a level up from this in terms of complexity. So take time to, thank you, Paige just put comments in the thread. I'm sure there'll always be a house of waffles. Please feel free to read the notes, to study this paste section. I guess I'll just put that in chat, although I'm sure Paige, it's too big. I'm sure Paige has the notes. Please make sure you feel comfortable about this. If there's any questions you have them, put them in House of Waffles or the chat before next time, because basically next time I'm going to assume you're already comfortable with the majority of what's here. Cool. I'm going to stop recording. It appears to have recorded all the way to this point.